So the first question is, sorry, my pen. First question is pretty standard. Like you just differentiate it using the product rule. So you differentiate this and then multiply it by this one, and then you differentiate this and you multiply it by this one. So you get dy dx is 2x sine x plus x squared cos x. It's only 1 mark, so you probably wouldn't have to share any working out. Second question, so you have fx and you need to find f dash 1. It was not really a trick, but just for the first question, always be careful that even though it's a and b, like b is not linked to a, so you're not finding f dash 1 of this. You're finding f dash 1 of the new function. So to find f dash 1, we first have to find f dash x. And that would be using our chain rule. So we differentiate the inner function and then the outer function. So we have this one, x plus 3, and then f dash 1, you just put 1 in here. So 2 minus 1, e 1 minus 1 plus 3. And the 1's cancel out, and you're just left with e to the 3. So for 2 marks, was probably 1 mark for your f dash x function and 1 mark for your answer. So probability question. So I highlighted like the kind of important information. So the first thing to note with this question is that it's it's like you're gonna use a Carnot map for it. I guess it's binomial because you can assume that a car either needs an oil change or air filter change. It needs one of them. Can't not have any of them. So you can assume it's binomial, but the main thing you have to realize is that you're going to use a Carnot map for this. And you can kind of see that with the wording, like the word both, that means intersection. If it was or, that would be union. But for this question, it says both, so intersection. And air filter change without an oil change. Without an oil change is kind of similar to when you're like A intersection B naught. So you're saying like this without this. So like those are just hints in the wording. So you might like pick up what you need to do in the question in reading time. So if you see like both, if you see intersection, big hints, I guess, that it's going to be a Carnot map. So you would draw your Carnot map like this. O is oil change and A is air filter change. So something like this. And the bottom right here always has to be 1 because the total probability is 1. So then you can start filling it out with the information that we know. So the requiring an oil change is 17 out of 20. So that doesn't mean only requiring an oil change. That means requiring an oil change in total. So that's the n probability. And then we can fill in this box because we know that total has to be 1. So this would be 3 on 20. And then we can fill in the air filter change because it's 3 on 20. And again, we know this is 17 on 20. And then it says the probability of both is 1 on 20. So again, like I said before, both is intersection. So intersection is this box, and it's 1 on 20. This is why reading time is important, because if you don't read the question, you might waste time and fill in the rest of this. But you don't actually need, you only really needed to fill in this box and this box. Because what you're trying to find is air filter without an oil change. So that's this one. Yep. So yeah. So you don't really have to fill in the whole thing. You can just, oh, sorry, it's not this one. The wrong box, it's this one. So you don't really have to fill out the whole thing. Just like be like, I don't know how to say, like beware of reading time, what you actually need to find. So air filter without an oil change, easily you can just pick it out from your graph. That's 2 on 20, and always simplify fractions. So it's 1 on 20. I mean 10. So next question. This is also an important one that you have to read the question because it says determine m in terms of n. So you actually don't have to find what m and n are. You just have to find m in terms of n. Hopefully you guys didn't waste a lot of time on that like me, because I didn't read the question properly. But yeah, that's all you needed to do. So this question is kind of a extremely generalized version of this one. So they got rid of all the numbers and they just replaced it with pronumerals. So you would generally, if you get questions of this kind, you approach it like almost exactly the way you approach the first question, except without numbers. So first thing we do is we draw a Carnot map. Oh, that's not. So air, not air. And then bottom right is 1. So things we know is that oil change is m on m plus n, and air filter change is n on m plus n. So we can fill out, well, unlike the other one, we do want to fill in most of the boxes, but not all of them. Just enough so we can kind of see what's happening. But like, if you don't know like what's happening, you can just fill all of them out, because you'd probably get a broader scope of what's going on. So you can already see that this line here, oh, I didn't fill this box in, m plus. Some of these boxes have the same thing, like this one and this one and this one and this one. So that's important to note, but not really at the same time. But yeah, so now we know the question's asking find m in terms of n. So if we're trying to do that, we can pretty much use any of these boxes to do that. But the easiest one to use would be 1 on 20 plus, so this one. You could pretty much use any of them, but this, like, you have to make sure you use a row that has 1 on 20 in it, because otherwise, if you take this one, for example, m minus 1 on m plus n plus 1 on m plus n equals m plus n, and you try to find what m is, you'll notice that you don't get anything, you just get 0. So make sure you use one of the, oh sorry, no dash, one of the rows or columns that has the number that they gave you in it. This number is not that one, by the way. So you could use this one or you could use this one. I chose to use this one, but they're both the same. As you can see, like what I said before, you can start noticing patterns. So these two columns are exactly the same. So 1 on m plus 1, n plus 1 on 20 equals n on m plus n. And then you just rearrange, or well, first we'll make it, oh, actually, you can move this to the side so you get rid of the weird fraction thing, and then you can cross multiply. So you get m plus n equals 20n minus 20. And then you see that you have m on your own now. So you get m equals 19n minus 20. And that's it. So yeah, just make sure you read the question. Don't waste time doing things they didn't ask you to do. So for this question, we have a tan graph and they give us 2 points. And you can see we don't know 2 things. We don't know A or B, and we have 2 points. So like the first thing that you should think of is simultaneous equations, because you have exactly the right amount of information for the things that you don't know. They also give you this thing, x is continuous from -1 to 1. It's not really important, but just good to keep in the back of your mind that the whole thing is like there's no gaps anywhere. So yeah. So simultaneous equations, first thing we have equation that we don't know, and the first point we do know, so 1 on 1 root 3. So you can sub that in, x plus, a plus b, sorry. And you notice that root 3 is actually an exact value, and we know values of tan that give us root 3. It's going to be pi on 3. But we know that because of symmetry properties, there's two things that could equal root 3. It could be pi on 3 or it could be 4 pi on 3. So to choose which one it is, we look at the graph, and we see that the point 1√3 is here. And we don't know what the period is, but this would be pi on 2a. So we can't really do anything yet, so we'll just keep that in mind. But the second point, so √3 could equal pi on 3, or it could equal 4 pi on 3. Oh, not √3. A plus b equals pi on 3, 4 pi on 3. So the other one we have, is y equals tan ax plus b, and we can sub in -1 and -1. So -1 equals 10 b minus a. Now for this one, we also know there's two answers. It could be negative pi on 4, negative pi on 4, or the other quadrant that tan is negative in is the second quadrant. So it could be 3 pi on 4 equals 10 b minus a. But for this one, we can actually get rid of 3 pi on 4 because you see that the point here is to the left. So it's going to be a negative value. So we can use -4. So we get b minus a. Oh, sorry, this is b minus a. It's negative pi on 4. And for this one, we can use pi on 3 because you can safely assume that it tells you that a is greater than 0. So if you make this bigger, the frame at which the scope of numbers you can use is smaller, so you get rid of the bigger value. So then you're left with two simultaneous equations. So you have a plus b is pi on 3, and you have negative a plus b is negative pi on 4. So you can add them or subtract them. I chose to add them because you could get rid of a easily. So pi on 3 minus pi on 4. So b is pi on 24, and that's one of your answers. And then you can sub that back into here. So a plus pi on 24 is pi on 3, and you should get a is 7 pi on 24. If you finish a question and you think your answers are kind of weird, leave it for now because technically you've fulfilled all the conditions that they give you. But if you still think it's weird, you should come back in checking time and sub these, rewrite your tan equation using these values that you found, and just make sure they work for both points, and then you can be absolutely sure that your answer is correct. So question 4 is just your standard log equation. You could do this quite a few ways. You could make this in terms of log 2, like you could do this, or you could just get one term on the left side and make this 2 to the power 1. I chose to do that, but first we have to get rid of the coefficient, so we can use the log p rule. So log 2x plus 9 is 1, and then if you minus logs, use divide them. So log 2 x plus 5 squared divided by x plus 9 equals 1. And then I chose to do 2 to the power 1 equals x plus 5 squared x plus 9. So 2x plus 18 is x squared plus 10x plus 25. And if you simplify that, you get 0 equals x squared plus 8x plus 7. So then you factorize, and you get x plus 7 and x plus 1. So now we have two answers. But the thing with the log questions is that usually one of the answers is wrong. Usually it's obvious because you'll have a term in here like ln x, and then the negative one is wrong because ln of something negative is undefined. But in this question, both answers are negative, and it's highly unlikely that they gave us a question with no solutions. So you sub it into the middle parts of each log, because that's kind of the criteria of if it works or not. The inside of a log always has to be greater than 0. So if you sub -1 into here, you get so you get 8 and you get 4. So they're both greater than 0, so you know x minus 1 is an answer. But if you put -7 into here, you get 2 and -2. So the 2 works, the 2 is fine. But you can't put it into here because you won't fulfill the conditions of the log without the modulus sign. You might think like technically you absorb the 2, so you square it, so like anything negative becomes positive. That's not how it works. In its simplest form, it must be able to be positive. So you can get rid of this answer. So since you can say something like x plus 5 is greater than 0, sorry, x has to be -1. Since I think you'd wrote this one. Yeah. So probability again. So saying for a certain population, the probability of having this gene is 3 on 5. Saying the probability of the gene is independent. So the independent thing is like important because you know there's questions where it's like someone goes to the shops and they buy like a drink, and then if they buy a drink that day, then the next week they buy like food. That's not independence. That's why it's good to note that they're telling you it's independent. So yep, it's just like random stuff that you should keep in head. So the question says, is a group of 4 people, and what's the probability that 3 or more people have the gene? So this is binomial. We can easily see that the 2 criteria are either has the gene or doesn't have the gene. So if there's 2 things, we know it's binomial. So it's asking for the probability. We'll let I probably shouldn't name it P. Probably we'll just name it X. Like X equal number of people with the gene. So the probability that X is 3 or more, so X is greater than 3. And this is binomial. So we have 4 people, so it's 4 choose 3. Or you could also write that as 4, 3, either way. 4 choose 3. And the probability of having the gene is 3 on 5, so 3 that to the power 3. And then not having the gene is 2 on 5, so that's to the power 1. Oh, sorry, I should write what I'm doing. So if you have more than 3 people, that means you have 3 people or you have 4. Those are the only 2 options because you have a maximum of 4 people. So you could either have 3 or 4. So this would be 4 choose 3. This is 3 to the 3 on 5 to the power 3, and then the probability of not having it to the power 1, and then plus 4 choose 4. 3 on, so the probability of having it to the power 4, and then the probability of not having it to the power 0, and then all you have to do is simplify. So we know the combinations is like this. And you could see that the denominator, okay, not for this question, but usually the denominator will be the same because you'll have like the same amount of powers added here, so the denominator would be the same. But anyways, so you have 3 to the power 3, so 27 times 2 on 5 to the power of 4, which if you do it like on the side somewhere, because unless you know what 5 to the power 4 is, but yeah. And then so simplify the other side, 4 minus 4 times, so 3 to the power 4 is 9 squared, so that's 81 and 625. So you can see the denominators are the same. Then you just keep simplifying it, but eventually you get 297 on 25. Yeah, so just be careful of your algebra when you're simplifying it, because things can go wrong. And be careful with your factorials, because 4 minus 0 factorial here is not 0. 0 factorial is 1. So just be careful of things like that, and it should be fine. So next question is, we have another group of 4 people, and now it's asking what's the probability that exactly 2 of them have it given. So that's a condition that's important. That at least one has it. And then the most important part of the question is it's telling you what form it is. And then it's also giving you some conditions. Just the conditions are important. So when you have an answer at the bottom, you can kind of verify that it's correct or that you've done it correctly, because otherwise if you get like fractions instead of integers, you've done something wrong, or that you have the correct answer, but it's not yet in the correct form. So conditions are important to like check at the end, or to check while you're doing it, so you can like make decisions in your algebra that get you to the right place. Basically, the question's asking what's the probability that x is exactly 2 equal, given that x is at least 1. So we know with, I'll just wait, I'll write that later. So we know if we expand this, it's going to be the intersection between this. So if it's greater than 1, greater than or equal to 1, and it's also 2, well, the only intersection is at 2 for both of these conditions. So it has to be x is 2. And then the given condition underneath. And as I was saying before, if we ever have an at least 1, we always rewrite that as 1 minus none, just for simplicity's sake, pretty much. But yeah, so now we can do 4 choose 2, and the probability of getting it is 3 on 5, and not getting it is 2 on 5. And then 1 minus 4 choose none. So that's 3 on 5 to the 0, and 2 on 5 to the 4. So 4 choose 2 is 6. If, like, I'll just show it, I guess. So 4 minus 2 is 4 times 3 times 2. You can ignore the 1 because it's multiplication, so you won't really get anywhere. So that's why it's 6. But yeah, so then you can see the top part. So this is where it's important to keep this in mind, because you don't want to expand everything just so you can see how you might get to this form. So the top part, you can see you have 3 squared and 2 squared, and then the denominator of the bottom part, I'll just rub this out. The denominator of the bottom part, so like red, so this part, you can see it's going to be 5 squared times 5 squared, so that's going to be 5 to the power 4. So just make sure you keep everything as an exponent, just because you know the answer is also going to be in terms of exponents. And then the bottom one is 1 minus, so 4 choose 0 is 4. 4 minus 0, so that's 4 on 4, so that's 1. So it's going to be, so 3 on 5 to the power 0 is 1, so you can get rid of this entire term. And then you have 2 on 4 to the power 5 on 4. So the main problem here is that we have our denominator in an ugly form, so we want it to be a fraction. So we're going to use a common denominator for the bottom of the existing fraction. So we're going to take this part here and make it another fraction. So probably have to do that in one step. So you would do 6 times 3 squared times 2 squared on 5 squared. So that's the numerator for this, so this part. And divided by, just so we don't get confused, you can write it like this. divided by the denominator. So that's 1 minus 2 to the power 4 and 5 to the 4. So to make this a fraction, we make it common denominator. So 1 would be 5 to the power 4 on 5 to the power 4. And then it's like that. So you can see that this is going to be 5 to the 4 times 5 to the 4, 5 to the 4 minus 2 to the 4. And then you can see that the 5 to the 4s cancel out. So it's a great thing that we didn't expand it before, because otherwise we could have mucked up our algebra. So now we're left with 6 times 3 to the 2 times 2 to the 2, 4 to the 2, 5 to the 4, and 2 to the 4. So we can see we got close to our answer because we have our denominator in what appears to be the right form, and it fulfills the conditions, but our numerator is not yet there. So the thing with the numerator is you can see we have 6. So if we split 6 into its prime factors, we get 3 and 2 back, which is really helpful because we already have 3 and 2. So if we like expand it or multiply it through, we get 3 to the 3 times 2 to the 3, 2 to the 3, and we're left like this. But again, it's not yet in that form. We need a single term on the numerator, and we know we can easily rewrite this as 6 to the power 3. So we know the answer is 6 to the power 3, 5 to the power 4 minus 2 to the power 4. And that's our answer. It's in the correct form and it meets all of the requirements. So, yep, that's it. So question 6, find the domain for f inverse 1 and the inverse. So we know how to easily find the f inverse. I like to write fy equals x. You can write like, I used to write swap xy. It doesn't really matter, just as long as you give an indication of what you're doing. So x equals 1 on root 2 root y. So we want to square everything. And that's our graph. So f inverse x equals, you can write it as y, but I like to write it as f inverse x equals something, because technically the question's asking for the rule of f inverse x. So maybe just be careful of that. I'm not sure. I don't think they'd be so mean as to take a mark for that, but yep. So the next thing we need is domain. And we know the domain of f inverse x is the range of fx, unless it's a special circumstance, but most of the time it's not. And luckily for us, they've given the graph of fx. So we look for the range, and you can see the range is from here to here. So that would be from 0 to 1. So the range of fx is the domain of gx. So the domain of f inverse x, sorry, is 0 to 1. And always be careful of the brackets. In this case, they're both inclusive because we have solid dots. So now we have to sketch f inverse 1. We have to label the endpoints and the points of intersection and give their coordinates. So label the endpoints. So we know the endpoints are going to be the switched versions of the endpoints of fx. So for f inverse x, this would be 1, 2. For f inverse x, this would be 0, 0. It doesn't really matter because both numbers are the same. They're both 0. But this point does matter. So this becomes this point. And the other point that, 0, 0 was, I know it's already labeled, but it technically did ask us to label it, the endpoints, so I would label it again. They can't take a mark off, so better to be safe. Next thing is points of intersection, so that we know they intersect on the graph of y equals x. So that's any point on the graph where it's xx or xy, where both the numbers are the same. So we can draw our graph of y equals x to help us locate those points. And you can see that there's a point right here. So we can see that there's a point here, but it might not be, so it's always good to check whether that point is actually half-half. So we have our graph of fx. Always, maybe not always, but maybe use fx instead of f inverse x in case you accidentally made an error in this question. So your graph of f inverse x might be wrong. So just use fx to minimize chance of error, I guess. But so f half is 1 on root 2 times square root of 1 on 2, so that simplifies to half. So x and y are the same, so we know that point is in fact half-half. So we can see that the graph, if I redraw, that's y equals x. So it's gonna go something like this. Yeah. And make sure to label, sorry, label the point as 1, 2. And that's it. We've done everything. So next question, find the total area of the one region bounded by f and f inverse. So the first area they're asking about is this one. And the second area, and the other area bounded by f inverse, and line x equals 1. So the line x equals 1 is here. And the area bound by f inverse, and x equals 1, it's this area. So we want to find those two areas. So the first area we know we can easily find because it's just, we could do 2 times the area of one of the graphs surrounded by y equals x, or in this question, both of the equations aren't really that bad. We know how to integrate both of them, so you could even just do integration of fx minus f inverse x, but yeah, for this question, it doesn't really matter because it's pretty simple both ways, but I chose to do x anyway just because integrating x dx is easier than most other functions. So first area I'll take to be the one, I'll take to be this area here, this one. So area 1 is from 0 to half. So that is twice the integration of the line y equals x minus the parabola, or f inverse x. So that is twice x squared on 2 minus 2 on 3 x to the power of 3, half to 0. And if you simplify that, you get 1 on 12 units. Units squared, just because they didn't tell us what the units were. And also it's an area. An area usually has units. Like if they asked us to just integrate this, then I wouldn't have put units. But since it's asking for the area, just good to have units, I guess. So the second area, sorry, this is area 1. So the second area is from half to 1, and that's this weird area here. So for that one, we can't really use y equals x. But we can just do our normal integration of the top function minus the bottom one. So the top function in this case is the parabola, so it's 2x squared minus 1 on root 2 root x dx. And that is 2/3, 2/3 x to the power 3 minus 1 on root 2 times 2 on 3 times x to the power 3 on 2 from 1 to half. And if we simplify that, we get 9 minus 4 root 2 on 12 units. So the total area would be the addition of these two. So A1 plus A2, and that is 1 plus 9 minus 4 root 2 on 12. So it's 10 minus 4 root 2 on 12. And if we get rid of 2 from both the denominator and the numerator, 5 minus 2 root 2 on 6 units squared. And that's we can verify our answer, double check it using the conditions, like I said before. So do we have 6 on the denominator? Yes, we do. Do we have something root the same number? Yeah, we do. And is a none of the other numbers? Yes, it is. And they're all positive integers. So we can be pretty sure that our answer is correct. So question 7. So show that the point P is not on the graph X. So P is the point 1, 0, and Fx is x squared plus 3x plus 1. So you would say, what is F1? So F1 is 1 plus 3 plus 5. F1 is 9, which is not equal to 0. Therefore, 1, 0 is not on the graph of Fx. So now they're telling us is a random point, could be anywhere on the graph. They don't give us any restrictions on A, so it really could be like any point at all on the graph. And it's asking you for the slope. So slope we know is just y2 minus y1 on x2 minus x1. It doesn't really matter which point you take as the top, I guess, or like y2 and y1, but generally I would take A as the y1, but it doesn't really matter. So y2 is f of A, and y1 is 0, x2 is A, and x1 is 1. So if you expand this, it's just fa because it's minus 0. So it's a squared plus 3a plus 5 on a minus 1. It would have been cool if this was like a quadratic with a minus 1 as a factor, but it's not. But anyways, so find the slope of the tangent to the graph at point Q. So slope of the tangent is not slope of the line connecting the points P and Q. The slope of the tangent is asking you what f dash x is at point A. So f dash x at point A is just f dash A. But to do that, we have to know what f dash x is. So it's just easily differentiate our quadratic, and then we can sub a in there, and you get 2a plus 3. So now they're saying they're going to let the tangent pass through P. So find the values of A. So from before, we found that the tangent at A, or rather the gradient of the graph at A, is 2a plus 3. And the point at A would be A FA, so this one. And so we have to find the equation of the tangent now. So we can do y minus y1 equals m x minus x1 and sub all these things in. M is f dash a, so it's 2a plus 3 x minus a. From here, you could like switch it around, find it as y equals mx plus c, but it's a bit of a waste of time because you would have to sub in p at any point, and it doesn't really matter when. So you could just leave it like that and sub p1 p in. So y is 0 minus a squared plus 3a plus 5 equals 2a plus 3, and then 1 minus a. We know to sub p in because this is the tangent of the graph at x equals a, and it passes through point P. So we know that at x equals 1, y has to equal 0 for the equation that we found. So that's why we can sub 1 and 0 in. So we effectively get rid of x and y, and we just have a, and we can find a through rearranging it. So yep, so we have 0 minus, I'll just negative a squared minus 3a minus 5 is negative 2a squared minus a plus 3. And we can switch it around, and you get this. Then we can factorize it to here. Equals 0, so a equals 4, or a equals negative 2. Usually when you get multiple answers for a question, you always make sure that they both work, that you don't have to cancel one of them out. But for this question, like I said before, a doesn't have any restrictions. It could be any point on the graph. And the question is asking for values of A, so you can be pretty confident that both answers are correct and you don't have to get rid of one. So that's that question. So next question, give an equation of one of the lines passing through the point P that is a tangent to the graph of F. So the question here literally asked us to find A values for this. So it literally asked us to find points on the graph where the tangent goes through the point P. So all we have to do for this question is take our tangent equation and sub in either value of A. So it's only asking for one. And the fact that it says lines can further, you can make sure that both answers are correct because it's insinuating that there's more than one answer for the previous question. So you could use this. I really wouldn't though, because you might get mucked up with the algebra. So I would rewrite all of the things that we use. So to make a tangent, so we need a point. We know the point. I used A is 4. So the point would be 4, f of 4, which is 433. And we need to know f dash 4, which is 11. So now we can use the same equation. So y minus y1 equals m x minus x1. So y is 11x minus 11. So if you think that answer is fishy at all or anything like that, you could either do it now or do it in checking time. You can sub the point P, so sub 1 and 0 into here, and if it works, good indication that your answer is correct. So next question, find the value of K that gives the shortest distance between the graph of Y that's been translated and the point P. So what not to do is what I did to begin with, before I realized, do not try to find a distance function because with x minus k, it's gonna be pretty hard. You'll end up with x to the power 4 in a square root bracket. It's gonna take a while to figure that out. So the easiest thing to do is figure out the shortest possible distance on just the graph of fx. So the graph we already have here, and it's at point P. So point P here, 1, 0. And you can see that the point at which the graph is closest to P would be the turning point of the graph. So somewhere around here. So the thing with this is that you don't actually have to find which point on the graph it is because it's a parabola, so you know it's going to be the turning point. Oh, sorry, wait. Yeah, I hope that makes sense, but yeah. So we know at this graph, the shortest distance occurs when x is, so turning point, we have x squared plus 3x plus 5, was it? Oop. Yeah, 5. So if you find the turning point of the graph y equals, you get x is -3 on 2. And then we have a translated graph. So in this graph, -k means it's being translated to the right by 3 units, not 3, sorry, k units. So if it's been translated to the right, the other thing that we have to know is that the shortest possible distance on the graph, so we have a parabola, it's been moved to the right, we have point P. So if we want to move it to the right as much as we want to get the shortest distance between P and a point on the graph, we know the shortest distance will be when the turning point is right on top of P. So, sorry, I forgot to mention that before. That's why we want the turning point of the graph. So the turning point of the graph is not the closest to P yet, but we know if we translate it enough to the right that it will be the closest point to the graph. So that's why we use the x value of the turning point here. So -3 on 2. And then we just need to know how many units to translate it to the right so that the turning point is directly on top of P. So basically we want to make, so the point P is 1, 0. We want to make 3 on 2 equal to 1. But to do that, we have to obviously add something. The something would be K. So K is 1 plus 3 on 2. So K is 5 on 2. So yeah. Yeah, that's pretty much it. So for this question, we have x, ln x graph, and they give you some conditions. So we know that the graph is not defined from 0 to negative infinity, and that makes sense because we have a log function. So find the coordinates of point Q, and Q is the minimum. So the minimum we know occurs at f dash x is 0, so f dash x, if we use our product rule, is this one. And then we have to let this equal 0. So 1 equals ln x, negative x equals e to the -1, x equals 1 on negative e. Don't get this mixed up if you're in a hurry and think that it's undefined. It would be undefined if it was x equals ln -1. It's the thing that's in ln that's important. Because if you remember like your graph for ln, its range is pretty much negative infinity to infinity. So this value can be anything. Yep, so we have A, but it's asking for the coordinates of Q, so we need to find f of A, so 1 on A times ln 1 on E, sorry. And we know 1 on something, 1 on A is the same thing to the power -1. So we could take out -1 ln E, and then log E is just 1. So this becomes 1 on E. So the point Q is 1 on E, negative 1 on E. So now it's integration by recognition, or you can kind of assume that's what they're going to make us do. So first we have to differentiate it. Oh, no, sorry, they've already differentiated it. So yeah, it is integration by recognition. So we have dx of x squared ln x equals 2x ln x plus x, and we have to isolate x ln x. So we can move this to the left and divide everything by 2. So x ln x is half ddx x squared ln x minus x. And now we want its antiderivative, so we're gonna introduce the integral on both sides. We can take out half as a coefficient, so dx of x squared ln x minus x. And if this is like the canceling out of the integral and the differentiation part, so we get back our original equation. So this would be x squared ln x, but we actually have to differentiate this part because it's not ddx of something. So, but we easily know it's just x squared on 2, and if we expand this, x squared on 4, integration x ln x dx, and we get what they wanted. So that's all we have to do. So now it's asking find the area of the region that's bounded by this graph, the line x equals a and the horizontal axis, where b is the x-intercept. So it's asking for this area. So there's two things we have to note is that the area is, or the signed area is negative. So when we put our integral, it's going to be negative something. And second thing is that our range of values that we integrate from would be from b to 0, and then we realize that we don't actually know what b is. But we do know that b is the x-intercept, so we can easily find that by just subbing that y of 0. So y is x ln x, then let y equals 0. So it's not going to be x equals 0 because if you remember from the very first part of the question, the graph is not, there's no graph at 0, so it's not 0. And you can also kind of just tell by looking at the graph that we're looking for the second answer, not the first one. So the other, if x is not equal to 0, so since x is not equal to 0, then ln x must be equal to 0, according to the null factor law. So e to the 0 is x, so x is 1. Therefore b is 1. So now we can actually write out our integral. It's going to be negative because we saw that the area would be negative. B to 0, fx dx, so x ln x dx. And this is why they call it integration by recognition, because you pretty much just have to recognize that you've already, actually this part is the recognition part. You already did that in this question. So you just sub this part into here, so it's negative x squared ln x on 2 minus x squared on 4 from 1 to 0, and just be careful of your algebra when you expand, but you should get e to the e squared minus 3 on 4e squared units squared. So part D, find the value, you have a new graph. It's just being translated up by k, and it's defined from a to infinity. So we no longer have this part of the graph. This part of the graph doesn't exist. It's just a line like this now. It didn't really affect the question that much, but it's good to be careful of things like that in case it does. Like, for example, if it asks for x-intercept, and then this part of the graph wouldn't exist, so you'd only consider this part. But anyways, so find the value of k for which y equals 2x is a tangent to the graph of g. If y equals 2x is a tangent, then at one point on the graph g dash something, call it alpha, has to equal 2. And we want to know the value of k for which. So if you can't just observe g dash x is going to be f dash x plus 0 because k is a constant. So you can tell by just having this information, we can't find out what k is, because as soon as we do g dash x, we'll get rid of k. So the other thing we know is that at a tangent, not only is the gradient equal, but it actually touches it. So there's a point here where both the point on the tangent and the graph are equal. So, and at the point of g alpha, we do include k in that equation. So that's the other piece of information that we need to see. But first, we have to find out what point that is. And to do that, we have to know when the graph of g dash x is equal to 2. So we find g dash x is just f dash x, like I said before, which is ln x plus 1. We already found that in another part of the question. So now we let it equal 2 to find when the graph has the same gradient as the tangent. So if we do this, we get x equals e, just right, equals 1, so therefore x equals e. So now we know that at the graph, at the point E, there's a tangent, and it's y equals 2x. But the other thing we know is that at this point, it's going to be 2e, because if we sub e into here, we're going to get y equals 2e, and the tangent also has to cross through that point. That's why we know the point is 2e. But the other way of finding what the y value is by subbing it into here. Sorry, not here, but here. So g of e is f of e plus k, and we know g of e has to be 2e. F of e, if you look on the previous question is E ln E plus K. So K is 2E minus, so this is 1 minus E, so K is just E. That's pretty much it. So last question is the one you have to be wary of, I guess. So it's asking values of K for which the graph of G and G inverse do not intersect. So G inverse is just a vertical translation of this graph. So it's asking how far you need to move it up before it no longer intersects its inverse. So its inverse probably looks something like this, but it's not really important. The thing we need to know is that if it's going to intersect its inverse, it's going to intersect it on this graph, y equals x. So all we have to do is make sure the graph doesn't ever touch y equals x. And the way to do that is, like I said, you have to translate it up by a certain amount. So we have to move this graph up enough to make sure it doesn't touch y equals x. The wrong thing to do is what I did would be to assume that you just have to move the turning point above y equals x. So what I did was I found a, and then I was like, just move it up by 1 on A, 2 on E. That's not what you have to do, because even if you have moved this up enough, so even though if your turning point is not, like your turning point is not touching the graph of y equals x, that doesn't mean your whole graph is not touching it, because you can see the graph is kind of on a slant. So what you have to do is make sure that you move it enough so that this point here, this curve, doesn't touch it. And the way to do that is to find when the graph is parallel to y equals x. So g dash x is ln x plus 1. And when it's parallel to y on x, g dash x, g dash x equals 1. So let g dash x equal 1. And x plus 1 equals 1. So x equals 1. Oh, yeah. So that means that at the point x equals 1, the graph is parallel to y equals x. So if you remember from when we calculated b is actually 1. So at the x-intercept, that's when the graph is parallel to y equals x. So now all we have to do is, like I said, move this point so far up that it never touches y equals x. So at y equals x, if b is 1, then like the y value would also be 1. So we just have to move it more than 1 above here. So that's why the answer for this is k is greater than 1, because you just have to make sure that this graph never touches y equals x. Yep, that's the whole paper.